Okay, so what this is, like I said, this could be a whole unit for me to teach, but it's called sequences. I am supposed to teach you about arithmetic sequences and geometric sequences, and you've kind of already learned them. Arithmetic sequences are linear equations, okay? So what is a series of terms where the same number is added each time to produce the next term? That is called an arithmetic sequence. And like I said, those are your linear sequences. The next one is a series of terms where each term is multiplied by the same number to produce the next term. What do y'all think that is, based off of what I've taught you? Think of the different functions I've taught you. I've taught you linear, exponential, and quadratic. What is that? If I multiply by the same number every time. It's an exponential function, but this is called a geometric sequence. But if I was to graph it, it's exponential. So you've already learned these. Now, what you need to understand is that there's two formulas you can write to find any term in a sequence. The explicit formula is a formula you can use to find any term. It works every single time. But this right here does not have to be taught in Algebra 1. So I'm not going to teach it to you. It's actually the easier formula to use, but this formula, a formula that relies on the previous term for finding each term in the sequence where the first term is given to you, this is called the recursive formula. This is the one that the state of Texas says I have to show you. So this one right here. And you'll notice that I took out the explicit because you don't need to know it. Now, it looks hard, but I promise it really, really isn't. Okay? So, what does it say arithmetic sequence is? It's a sequence where the same number is added or, of course, subtracted, right? So if I'm looking at a sequence and I add the same number every time, it's arithmetic. To write a recursive formula, look how hard it looks. It looks like super confusing, but I promise it's not. A sub 1 means the first term. Where can we write that at? Like if you see this, that just means what is the first term in the sequence? And if you see this, a sub n minus 1, this means the previous term in the sequence. And I know this sounds confusing, but I promise you'll catch on. It's super easy. All right, so I'm going to say it again. An arithmetic sequence is a series of terms where the same number is added. So like if I started with 1, then my first term, my a sub 1 would be 1 because that's the first term. Let's say we want to add 3 each time. Well, what would the second term be? 4. What would my next term be? 7. I would just keep adding 3. To write the recursive formula, you simply write a to the sub n minus 1 plus 3. This is the common difference. That's what you're adding. And all this means is the term before it. So it's just saying take the term before it and add 3. That's all the recursive formula is. This will always say a to the n minus 1 because it's basically saying take the term before it and add 3. Make sense? Yes or no? All right. Let's go look down here, and I want you to find the arithmetic sequences. Which ones are being added the same term every single time to give you the next number or subtracting the same number? So let's look at this one. How can I get from 0 to 1? Plus 1. Would I also plus 1 to get from 1 to 2? Yes. How about 2 to 3? So is this an arithmetic sequence? Yes, so I would write it right here under arithmetic. 0, 1, 2, 3, 4, 5, 6, dot, dot, dot. It keeps going. What is the common difference? What are they adding every single time? Plus 1. That's your D. What is the first term? 0. So the A sub 1 is 0. Or you could say F of 1 is 0, just how you're looking at it. We don't care about the explicit formula. The recursive formula is super easy. It says, to find the term you're looking for, this is the term you're looking for, take the previous term and add what? And add 1. That's it. That's all you have to know. All right, I want you to find the next arithmetic sequence. In this list up here, what's the next one? Did y'all find it? Look at this one. Is this arithmetic? All right, let's start right here. How would I get from 10 to 16? Plus 6. How would I get from 4 to 10? Plus 6. How would I get from negative 2 to 4? Plus 6. How would I get from negative 8 to negative 2? Plus 6. So is it arithmetic? Yes, so I'm going to write that right here. What is the common difference? Plus 6. What is the first term? Negative 8. So F of 1 is negative 8, or you could say A sub 1 is negative 8. These mean the same thing. They can be written either way. We don't need the explicit formula. I want you to write the recursive formula. It's going to look just like this, but you're going to plug in something different here. Go write it. So it says to find the term you're looking for, take the previous term and add 6. Yes? Everybody got it? All right, find the last arithmetic sequence. Look at this one. To get from 2 to 6, I would plus 4, but to get from 6 to 18, would I plus 4? That's not arithmetic then. So let's look at this one. To get from negative 5 to 10, what would I do? Plus 15, but to get from 10 to negative 20, that's not going to work. All right, look at this one. To get from 31 to 27, I would subtract what? Okay. To get from 27 to 23, I would subtract 4. From 23 to 19, subtract 4. And from 19 to 15, subtract 4. Is that arithmetic? Yes, so I'm going to write that right here. What is the common difference? Minus 4. What is the first term? 31, also called A sub 1. The recursive formula says to find your term, take your previous term, that's your term minus 1, yes, and subtract 4. And that's it. Are we okay? Now let's look at our geometric sequences. These are your ones that increase or decrease exponentially. You're multiplying. So look at this one. These are obviously going to be our geometric sequences. How would I get from 2 to 6 by multiplying? Times 3. How would I get from 6 to 18? Times 3. How would I get from 18 to 54? Times 3. That is a geometric sequence because it's multiplying. So 2, 6, 18, and 54. This is not a common difference. This is a common ratio. So what was my common ratio? Times 3, or you just put 3. What is the first term? F of 1 is equal to 2, or A sub 1 is equal to 2, because 2 is the first term. Yes? We don't need an explicit formula. For the recursive formula, it's going to be written the same way. To find your term, take your previous term and multiply by 3. And that's it. Okay, let's look at the next one right here. What would I multiply by to get from negative 5 to positive 10? Times negative 2. What would I get? How would I get from 10 to negative 20? Times negative 2. How would I get from negative 20 to 40? Times negative 2. So this is geometric. My common ratio is negative 2. My first term is negative 5. Or we could say A sub 1 is negative 5. That means my first term. And I want y'all to write the recursive formula. To find my term, I take my previous term and multiply by negative 2. All right, try the last one on your own. Oops, times 10. All right, y'all think that's easy, right? Now, like I said, the past few STAR tests, there's only been 3 questions over this in like the past 7 years. So flip to the back, and these are the 3 questions that they asked. Okay, so we're going to go over these together just to show you what they could look like. So let's look at the first one. It says, in a sequence of numbers, what does this mean, A sub 3? The third term. The third term is 0. The fourth term is 6. The fifth term is 12. The sixth term is 18. And the seventh term is 24. Based on this information, which equation can be used to find the nth term? Meaning, which of these equations would help you find any term? So, here's what you do. Make a table. What did they tell you? The third term is, so could I say the third term is 0? What could I do for this one? The fourth term is 6. The fifth term is 12. The sixth term is 18. The seventh term is 24. Now, the next thing I need to kind of figure out is this arithmetic or is this geometric? So don't look at the terms. That's your x's. Look at the y's. What's going on between the y's every single time? Plus 6, plus 6, plus 6. Now, that does not mean that's your rule because the first term is obviously not one of those. But could I use stat to get a linear equation? Because if I graph that, isn't that linear? Yes. So I go to stat, edit. If it's linear, I only have to put in a few. Stat, calc, option 4. And there's your equation. Y equals 6x minus 18. So the answer was C. So all they wanted you to understand in this problem is that a sub 3, the third term, is 0, and that you could make a table. That's all they wanted from that. Does that make sense to y'all? All right, let's look at the next one. A sequence can be generated by using this formula. Isn't this the recursive formula? What are they saying to multiply by right here? 4. And they're telling you the first term is 6. So if the first term is 6, and they're wanting me to do what? Add 4 or multiply by 4? Multiply by 4. What would the second term be if I multiplied by 4? 24. What would the third term be? Well, I would do 24 times 4, which is 96. So the answer is F. What did they do wrong on G? They added 4, but this was obviously a geometric sequence because it said to multiply by 4. Does that make sense? All right, let's look at the last one. The first 6 terms in a geometric sequence are shown below, where the first term is -4. Based on this information, which equation can be used to find the nth term? I made a table. It just helps me. I said the first term is -4, the second term is -16, the third term is -64, the fourth term is -256, and then I found the common ratio. What is 16 divided by 4? What's 64 divided by 16? 4. So they're obviously multiplying by 4. Yes? Yes or no? And isn't this an exponential function? Remember what I told y'all? If it's increasing, it's exponential. So this can go, because that's not exponential. An exponential function has an exponent. And they're multiplying by 4. So what I did is I used my y equals button to see which one of these would give me this table. So I went to y equals, I think this is what I did, and I typed in B, negative, open parentheses, 4, close parentheses with an exponent of x. And I said, would that give me this table? 1, -4, 2, -16, 3, is it working? So that's it. I didn't use stat because of all these weird negatives. I didn't think the calculator would do it for me. So I used the answer choices. Now again, in the past, like however many years, these are the only 3 questions that have been asked on this. Okay, so this is all the information I have to pretty much help you prepare for those questions if they even pop up. Okay, again, just make sure you make a table if they give you something like that so that you can see the pattern. Got it? All right.